Start.
Hi guys, and welcome to another section of Connor's Math Lab. Today we'll be exploring a few problems related to the arithmetic and geometric sequences. So the first problem that I included is this. Find two distinct numbers p and q such that p, q, and 10 form an arithmetic sequence, and g, p, and 10, or q, p, and 10 forms a geometric series. So first of all, before we do any math problem, we should list out what we know, what we want, before thinking about the solutions. So in here, what do we know? Well, we know that p, q, 10, this sequence is arithmetic. And we know that q, p, 10 is geometric. So what do we want? We want to find p as well as finding q. So looking at this, something that should get your attention is that you know two things, but you want to find two variables. So you could think about setting up an equation of two variables with two unknowns. So that is exactly what we will do in our solution. For the arithmetic sequence, corresponding terms must have the same difference. So q minus p must be equal to 10 minus q. What does this mean? This means that 2q is equal to p plus 10. At the same time, the geometric sequence tells us that p over q is equal to 10 over p, which means that p squared is equal to 10q. Listing these two, we can now identify that this is simply an algebra problem with two unknowns and two equations. So now we can simply go about solving this. Well, how do we start with this? We know that there's a p squared, but there's no p squared here, so we can't substitute p squared. However, the thing that we can do is that we can substitute 10q. Rearranging this equation gives us that p squared over 5 is equal to 2q. But why do we get this? Because now we can directly substitute p squared over 5 into 2q. This gives us p squared over 5 is equal to p plus 10. And if we solve this, we can multiply 5 on both sides. And then we can factor this. And finally, we get that p minus 10, p plus 5 is equal to 0, which implies that p is either 10 or p is -5. Which one of these is it? Usually in an algebra problem, when you get something like this, a good strategy is to read the problem again to figure out which one of the solutions is actually valid. Well, in the problem, we want to find two distinct numbers, p and q, such that that is arithmetic and that is geometric. Would this work when p equals 10? Well, no, because if p equals 10, then q must also equal 10. So p and q are not distinct. Therefore, the only solution is when p equals 5. Alright, so let's summarize a few things that I did within this problem. The first thing that I did is I clearly listed out what I know and what we know and what we want so that we could solve the problem easier. The next thing that I did was I tried to represent a complicated situation into a math equation so that I can further simplify it and solve it. And finally, when I got solutions, I tried to plug them in and see if they made sense. This is essential in solving any types of math problems. Alright, that's all for today. Thank you for watching Connor's Math Lab, and see you. Bye!
Wait, Lowell, do you want to sponsor